Hello guys, in this tutorial we will design a two-way switch using VHDL. First I will explain the code for the two-way switch in Notepad++ and will also create a test bench file for testing our design. After that we will create a project in Quartus Prime software and use this VHDL file to compile and simulate our design. Since we are using VHDL for designing our module, we will select VHDL from the language option provided in Notepad++. By selecting this, we will get syntax highlighting for our code. A VHDL design consists of two main parts. First is the entity and second is the architecture. Before defining the entity and architecture, we must include the libraries which are necessary for designing a VHDL module. For including the library, we will use the keyword library and we will use the IEEE library. Inside this library, there is a package called Standard Logic 1164. This package is used for describing the digital logic values and the vectors in VHDL. The entity is defined with the keyword entity. After that, we have to specify the entity name. For this project, we will use the name two-way switch. Then type is and end the entity with the keyword end and the entity name. The input and output of the entity are defined inside the port. We will use the keyword port. This entity will have two input and one output. Since the input A is a single bit, we will use standard logic. If the input are several bytes long, we can use standard logic vector. Now that we have defined our entity, let us save this file. While saving the file, keep that in mind that the entity name should be same as the file name. After defining the entity, we must define the architecture. Entity just defines the input and output of the particular block. What's inside the block will be defined in the architecture. There are various styles in which we can define our architecture, like data flow modeling, behavioral modeling, and structural modeling. In this project, we will use data flow modeling. The data flow modeling is one of the simplest type of modeling. To begin with the architecture, we will use the keyword architecture followed by the architecture name. We will use the name data flow. Then we will type off and we will type the name of the entity for which the architecture belongs. That is the two-way switch. Then type is, and to end the architecture type end and the architecture name. To start the architecture, use the keyword begin. Now we are ready to define the architecture. The logic to implement a two-way switch is very simple. We can implement the two-way switch using an XOR logic. The output of XOR between A and B will be directly assigned to C. This is the assignment operator used in VHDL. With this line, our logic is complete. Save the file. Now to test this two-way switch logic that we have created now, we will create a test bench file. Save this file with the name two-way switch underscore test bench. VHDL file has an extension .vhd. For creating the test bench file, the procedure remains the same. First we will include the library, then define the entity and its architecture. We will include the same libraries that we have included in our previous file. The entity in the test bench file will not have any types of input and output, so we will not define the port. We will directly define the architecture. For creating the architecture of the test bench file, we will use behavioral modeling. Hence, we will give the name behavior for our architecture. Then we have to specify the name of the entity for which the architecture belongs, that is the two-way switch TB. End the architecture with the end keyword followed by its name. As we are writing the architecture to test our previous file, we must include this file in our current design. We can include this by using the component keyword. We have to specify the name of the file, that is the two-way switch, and end the component. We also have to specify the ports of the two-way switch, so we can directly copy from the previous file and paste it here. Before beginning with the architecture, we have to define the signals that we are going to use in our architecture. These signals are useful to map with the input and output of this particular module in our design, because we have not defined any types of input and output in our entity. We will define three signals for the three input and output of the two-way switch module. We will assign a logic 0 for this signal while defining. We can do this as follows. Similarly, we will define two more signals. Now we can start with the architecture. Since we have used a component in our architecture, we have to initialize it at the start. Like in the higher level languages, we call a function. In VHDL, we can call a component, and this process is called as component initiation. First, we have to specify a name for our component. I have given the name ut and specify the name of the component, that is the two-way switch. Then we have to map the ports. use the keyword port map and use round brackets. Inside this bracket, we have to map the port of the two-way switch with the signal that we have created here. Now our component has been initialized. Now we have to define all the conditions that our input A and B can take up so that we can verify our output C. We can do this within a process. A process is a key structure in behavioral modeling. Process can be written in a variety of ways, and we will demonstrate the simplest way we can implement a process. First, we can write a name for our process. I will name it as stimulus process, followed by a semicolon and the process keyword. Start the process with the begin keyword and end it by end process. Within the begin and end, we have to define our process. As we can see in the truth table, there are 4 conditions for A and B. We have to mention these 4 conditions in our process. We can do this as follows. This line is useful to see our simulation. When we simulate, the this particular input will stay for 100 nanoseconds. The wait keyword will allow us to stop the simulation. Save the file and the testbench file is ready. Now that we have created a testbench file and a module for the two-way switch, we will implement these two files in the Cortex Prime software. Open the Cortex Prime software. Create a new project using the new project wizard. A step-by-step guide is provided in the quick start guide. I will fast forward through the process of creating a new project. The project has been created. Now we will add two VHDL files for our two-way switch module in two-way switch testbench file. Click on VHDL, copy the code for the VHDL module and paste it here. Save the file with the same entity name, that is the two-way switch. Create another file for our testbench file. Copy the code for the testbench file in the Cortex Prime. Save this file with the same entity name. Assign the previous module, that is the two-way switch, as the top level entity. We can find this option by right clicking here and set it as the top level entity. Start analysis and elaboration. We can simulate the two-way switch module in two methods. First, by using the testbench file, and second, using the simulation waveform editor provided in the Quartus Prime software. I will demonstrate both of these methods. First, I will demonstrate how to simulate using the simulation waveform editor provided in the Quartus Prime software. Before that, we have to compile entire project. Click on the Start Compilation option provided here. This might take some time. Now our project has been compiled successfully. Create a new file. Click on this option. Click OK. This will open up the simulation waveform editor. Right click in this section. Insert node or bus. Click on node finder. Click on list. This will list all the input and output present in the two-way switch module. Select all of these input and output. Click on OK. OK again. Now we have to provide a time period for A and B. Click on A and click on count value option provided in the toolbar. Enter a 100 nanosecond value. As we can see, the clock changes its state every 100 nanosecond period. For B, we will provide this period as 200 milliseconds. Save this file with the name waveform1. To get an output for C, click on the Run Functional Simulation option provided in the toolbar. As you can see, waveform for C has been appeared. We can compare this output with the truth table provided in the documentation. Now to simulate this module using this testbench file, we have to create a native link first. Go to assignment and click on settings. Click on model sim Altera. Make sure that model sim is selected. Since I have used VHDL module, I will click on VHDL. To create a native link, click on compile testbench file. Here we will select the testbench file we have created. This is our testbench file. Give the same name in the testbench name. Add this file. Click on OK. Click on OK. Select this file. Click on OK. Now we will start analysis and elaboration again. Now our design has been compiled successfully. Click on Tools. Click on RTL Simulation. This will open up the model sim software. Here we can see the waveform has been loaded automatically in the waveform editor section. Compare this output with the truth table provided in the documentation. This is how we can simulate our design using our testbench file in model sim.